Okay, for really a second day on 2.1, where we had an introduction to the derivative, and that's your tangent line slope, we had two formulas, and we were just talking about that before. You know, you can see right here, the one in the box was the slope of the tangent line. There was a second form that we could have also. And I'm just going to write this up here so that we can see it again. Both of these versions will allow you to find the slope of a tangent line at a particular a value. We had a question about number 8 here, where a is actually equal to -8. We had a request to use the first formula, the formula where we have a box. So we can see that the slope at that tangent line would be the limit as x approaches -8, and we'd have f of x minus f of -8, and down below here we'd have x minus -8. And hopefully it won't take you too long to see that really this tangent line slope that we're taking a look at will have the cube root of x. And f of -8, if we plug that in, the cube root of -8 is actually going to be a -2. So we'd say minus a -2. But of course, what's really going to happen here is this becomes an x plus 2. So I'll just space this out, stating the obvious. This is going to take a little creativity to get this thing to work out. Obviously, when we substitute in our -8, we get 0 over 0. And that then just begs the question, how in the world might we be able to work this thing out? And if you think about a conjugate, remember conjugates were with squares. Conjugates were with squares. So, the whole purpose for multiplying with conjugates was when you wanted to get rid of square roots. A plus b times a minus b was a squared minus b squared. What's the power of that? Well, you would have a difference of squares. The whole purpose for doing that was to get squares to cancel square roots. Here's the problem. You don't have a square root, you've got a cube root. You want to get rid of a cube root. So you'd think, well, gosh, do I have any knowledge about working out maybe a sum or a difference of cubes? I see a sum here, and hopefully you can say, well, wow, yeah, I do remember this formula right here. And we had the SOP formula, as we've said quite a few times. The SOP formula is definitely going to be same, opposite, positive. If this was a positive right here, we'd have the positive right over here starting. If this would be the same, I am so sorry. Here's your same, here's your opposite, and this is always going to be your positive right here with that factored form. That's assuming that you're starting right here. That's ultimately what I'd like to end up with. You see, I'd like to get rid of my cube roots. And, you don't multiply by a conjugate. That gets you a difference or a difference of squares right here. So tell you what we're going to do. We're going to come over this way. We'll say the limit as x approaches -8. Here's your a, here's your b, right? You can say, hey, I'm going to get, tell you what. So we start right here with the cube root of x plus 2. That's your a plus b. I'm going to multiply by this thing squared. That's a squared. Minus ab. Well, that's going to be 2 times the cube root of x. That's your ab switched, really. It's like ba. And then we'd say plus b squared. Well, that's going to be a 4. Now, that can seem crazy that you're multiplying the top and the bottom. In fact, let me even maybe first just say that we're multiplying the bottom by this exact same thing right here. This can seem just very strange. You can think, why in the world would you do that? Well, I'll tell you why. This numerator that you're going to have is really going to multiply into a cubed plus b cubed. What is the cube root of x cubed? What does that become? An x. Plus, what's 2 to the third? 8. Guys, that whole numerator will cancel. It's going to cancel. And then you're going to be able to see very fast something really good happening. Because the x plus 8s are going to go away, you no longer have 0 over 0. What do you do now? You got to plug that negative 8 in there. You could say, well, I'm going to have the cube root of negative 8 squared plus 2 times the cube root of negative 8 plus a 4 right over here. And the cube root of negative 8 squared, well, you could look at this also as the cube root of negative 8 and then squaring it if you'd like. That's definitely one way you could do it. Cube root of negative 8 is negative 2. Negative 2 squared is 4. So you'd get that 4 down there. This thing right here is negative 2. The cube root of negative 8 is negative 2. Negative 2 times negative 2 is another 4. And then we have a 4 right there. 4 plus 4 is going to get you 112. Now, guys, as we were checking our answer here, this was for number 8, you can see that we're getting 112 right in here. I'm running my cursor over that. The slope, when you plug in an a value of negative 8, you get 112. So that's really what Mr. Clifford wrote out. He wrote m sub a, that's m sub negative 8. And then, of course, you'd say, well, what point were we at? You know, from the very beginning, we were at the point negative 8 comma negative 2. So, you know, we have for our basic tangent line equation, we're going to see this. So it's going to be y minus a negative 2. Here's your 112. Then we'll have x minus negative 8. And that would be y plus 2 equals 112 all over x plus 8. Here's your tangent line equation. Here's your tangent line slope. So what you're going to be doing for your homework tonight, and I'm going to do this problem with you right now, is we're going to revisit this problem, but we're going to do the part A aspect of it. I'm going to just put in a little bit of space down here. We're going to say, what if, for part A, they don't tell you what your beginning point is at all? For part A, we're going to say, work this out for a comma f of a. In other words, you no longer know that it's at negative 8 comma negative 2. It's arbitrary. It's completely arbitrary. And let's go back to this original problem right up here. We're going to say the slope of that tangent. Well, it's the limit as x approaches a. The problem is I don't know what a is right now. F of a, well, that's the cube root of a. And down below, you've got x minus a. We've got to work that out. And it's going to be effectively the same problem. It's just that right now, you don't see that a was equal to negative 8, and you can plug it in. So it's working it out more abstractly. Well, here we go again, talking about if you plug in, if you were to substitute in your a right here, you'd get 0 over 0. We're revisiting what we just talked about. You know, you're not going to multiply by a conjugate. Conjugates, like we said earlier, are set up so that you get squares, a difference of squares. That gets rid of square roots. You multiply by conjugates when you need to get rid of a second root, a square root. We need to get rid of cube roots. So the big question is, do we have any link between a cubing kind of a formula? And we do. You can see real quickly, here we've got, you know, this a minus b. You could say, what if you ultimately want to wind up with a cubed minus b cubed. Well, what was the factoring formula for a cubed minus b cubed? It was a minus b, a squared plus ab. That's that SOP formula again, right? Plus b squared. The SOP means you're going to have the same over here. If you're starting off with a negative, if you would have a cube, then you're going to have the opposite, and then this last one's always positive. This is your capital A. This is your capital B. In other words, you're starting not with like one of your conjugates. You're starting instead with an A minus B. You're going to have to multiply it by something that looks way more complicated. And you can think, well, what's the whole purpose for doing that? The whole purpose for doing that is to get a sum or a difference of cubes. You could say, why do I want that? That's how you get rid of cube roots. To get rid of a cube root, you cube. So let's see if we could do this real quick. We'll have the limit as x approaches a, and here we've got our cube root of x minus our cube root of a, and here's a fraction. As long as I multiply the top and the bottom by the same thing, I'm going to be good. So I'm starting off here. The a minus b, guys, is what we have in yellow, right? That's what we're having right over here. What I'm going to have to multiply by is what's in green, right? So if we look at it this way, you'd say, hey, when I multiply the yellow and the green, then I'm going to get the blue. I'm going to get a difference of cubes. So hopefully that's helping you out. I need an a squared here. Here's my a. What's a squared? Well, it's the cube root of x squared. Then I'm going to say plus ab. I'm going to say plus, well, I'm going to have the cube root of x times the cube root of a there. That's cube root of xa if you'd like, or ax. That's your ab. Now I'm going to say plus, now I'm going to have my b squared. Well, that's going to be a plus cube root of a squared. Well, what you just multiplied up on top by, you're going to have to multiply the bottom by. That's how you keep a fraction to have the same value. Now, the whole reason why you did this, the whole reason for doing this is so that now that numerator is going to go to blue. It's going to be a cubed minus b cubed. So let's see what we've got. Just canceling out the top. Wow. You'd say, well, what is a to the third if you have the cube root of x? A to the third is just x. And what about b cubed? B cubed there, if I have my b, if I cube the cube root of a, that's going to be just an a. See, that's the whole thing that's happening right here. You've got this guy. Now, what about down below? Your whole numerator, it's like you don't have to FOIL it all out. Thank goodness. You just know what's going to happen. And then down below, we're just going to have to do some cleaning up. Hopefully, we can do that in just a moment. Okay, so you could say, look, your x minus a and this x minus a, they're gone. And then what? Plug in your a. You no longer have 0 over 0. You'll have the cube root of a squared plus the cube root of a squared plus the cube root of a squared. Well, I don't know about you. I see 3 of the same thing down there. Guess what your final answer is? 3 of these things right here. This is the tangent line slope for any a value that you'd like. Any a value that you'd like. By the way, now you can plug in a equals -8. And if you did that, to see what would happen, you'd say, well, I'd get 1 over 3 times the cube root of -8 squared. Guys, if you work that thing out, you're going to get 1 over 12, just like we did before. How about that? Now you've got a more general formula. Your homework tonight's to finish up the first 10 questions. Obviously, number 8 you don't have to do, but work it out for this general A case, just like we did right here.